Right, so rules for drawing any structure. First thing you want to do is add up the total number of valence electrons the substance has. Right, so for example, if I'm doing CO2 is going to be 4 for carbon, plus 6 for oxygen, plus 6 for oxygen because there are 2 of them, and that will give me 16 electrons I have to draw in. If my charge is negative, I add that to the total. So if it was CO2 minus, for example, I put in 17. If it was CO2 plus, I'd subtract from the total and draw 15. Alright, so first thing you do is add up. This is the total number of electrons you can put in your structure. The second thing you're going to do is you're going to put one atom in the middle and put everything else around it, top, bottom, left, right. Again, all 4 of those positions are equivalent. Now I'm going to give you some rules in the next slide for how to determine what to put in the center. But for right now, you're just going to put one in the center. The third thing you do is you place your bonding pairs between adjacent atoms. Right, so how I was forming the bonds like that, you'd start off forming the bonds and you'd subtract them through. And this will make a lot more sense when I actually show you the example. Fourth thing you do, once you've drawn your bonds in, give everything on the outside an octet. If you still have electrons at that point, put them on the center atom until the center atom gets an octet. If you've done this correctly, you will not have any electrons left over once everything gets an octet. If you happen to run out during this process, though, what you're going to do is you're going to start forming multiple bonds, so double bonds or triple bonds. You don't form these unless you have to. If you can draw a structure that obeys the octet rule with all single bonds, do it. Right, but again, notice that these elements you have here, it's pretty close to your response from last year. Right, these are the atoms that will typically form double bonds between them if you're going to form them at all. And the last thing to look at is, if you've done this process and you still have dots left over, you made a counting mistake somewhere. Go back and recheck your count. Now, general rule of thumb, carbon will almost always form 4 bonds. You will hardly ever see a lone pair on carbon. Nitrogen, you'll see 1 lone pair almost all the time, and 3 bonds attached to it in some combination of singles and doubles, or maybe even a triple. Oxygen, you'll usually see 2 bonds and 2 lone pairs. Again, these are rules of thumb. There are exceptions to these, but this will give you a good idea if your structure is kind of looking right. Now, when it comes to picking a center atom, 2 things you want to consider. First off, if you have carbon, it's almost always in the middle. Hydrogen, because it only needs 2 electrons, will never be in the middle. And fluorine will never be in the middle because fluorine never wants to really give up electrons. Right, so fluorine, never in the middle if you have it. So if you have carbon, put it in the center. Fluorine and hydrogen will always be on the outside. The other thing to keep in mind when you're looking at formulas is molecules tend to be very symmetrical. Right, so for example, one of the examples I'm going to show you in a bit is NH3. Right, so NH3, in this case, the nitrogen will probably be in the center. Right, I have 1 nitrogen, 3 hydrogen. It makes more sense for the N to be in the middle and the H's to be on the outside. Right, so keep in mind symmetry. And if worse comes to worse, just do trial and error. Just keep trying it until you find something that works. Right, so here are a couple of examples we'll work with. The first one is formaldehyde, so H2CO. First step I want to do is I want to add up the total number of valence electrons. Hydrogen has 1, so 1 plus 1 for the hydrogens, plus 4 for the carbon, plus 6 for the oxygens. That adds up to 12. Second thing I'm going to do is I'm going to figure out what my center atom is. Now for my center atom, look, I have carbon. If I have carbon, it's almost always going to be in the center, so carbon in the middle. Then I have to put 2 hydrogens and an oxygen around it. Top, bottom, left, right doesn't matter, so for sake of argument, I'll put my oxygen on top. I'll put 1 hydrogen here. I'll put another hydrogen here. So that's my second step. Make my skeleton. Third step, bonding pairs. So my first bonding pair is going to be that pair of dots there, a pair of dots here, and then a pair of dots here. I put in 6 dots, right? So I had 12 to begin with. I just used 6, means I have 6 more. So this is my running count. I've made my bonds. My next step, I'm going to work around the outside until everything has an octet or I run out of electrons. So look at my outer atoms. Hydrogen only needs 2, so that's good. Hydrogen only needs 2, that's good. This oxygen needs 8. It already has 2, so I need 6 more. 1, 2, 3, 4, 5, 6. I use 6 electrons. I'm at 0. I have no more dots I can draw. Right, so no matter what I do to this structure, I cannot put in any additional dots. Right, this oxygen now has 8, but if we look at the carbon only has 6. 2 on the left, 2 on the top, and 2 on the right. It needs 2 more to get a full octet. But I can't draw any more dots. What do? What I do in this case is, because I ran out, I make a double bond. I take electrons from an atom that has some to spare. So I'm going to take this pair of dots from my oxygen, erase them, and I'm going to move them into the bond. Right, so I can, if I need to, replace a lone pair with a bonded pair. And now if I look at my carbon, I have 2 on the left, 2 on the right, 4 on top for a total of 8. Oxygen is still 8, 2 on the left, 2 on the right, and 4 on bottom. This obeys the octet rule. Right, so this is a viable structure for formaldehyde. And if I replace the bonding pairs with dashes, which you are allowed to do, oxygen, and then I have 1, 2, 3, 4, then hydrogen and hydrogen. Right, so this is formaldehyde. Now why don't you try nitrate for a second? The key thing with nitrate to remember is that it has a negative charge. So you have to keep that in mind when you do it. So pause the video, try nitrate, pick it up when you think you have an answer. Okay, so first thing we have to do is we have to do our addition, right? So nitrogen starts off with 5. Oxygens. Each oxygen has 6. There are 3 of them. So that's 6 plus 6 plus 6. And the negative charges mean I add 1, so I go plus 1. So this total adds up to 24. So I have 24, right? 24 shall be the number of electrons thou shalt put in the structure. Thou shalt not put 25, nor shalt thou put 23, unless thou proceedeth to 24. 26 is right out. Thank you for indulging my little Monty Python there. I have to get it occasionally. So 24 electrons. Now we're going to figure out what goes in the center. Look at the structure, right? We don't have carbon, so it's not automatically in the center. What I'm going to do is symmetry. I have 1 N and 3 O's. If that's my formula, then symmetry is going to suggest that I put in nitrogen here, and then oxygen, oxygen, oxygen. Right? And again, I can move one of them down bottom if I want, doesn't really matter. Now I put in my pairs. 1 bonded pair, 2 bonded pair, 3 bonded pair. So 24 minus 6. That leaves me with 18. Now I'm going to work around the outside. 1, 2, 3, 4. This oxygen now has its full octet. 1, 2, 3, 4, 5, 6. Now the top one does. 1, 2, 3, 4, 5, 6. Now this one on the right does. I placed in 18 dots, so again, I'm out of electrons. Oxygen has 8, oxygen has 8, oxygen has 8, nitrogen has 6. So now I have to do the same thing that I did for formaldehyde, which is take one of those pairs and make a double bond. Here's the cool thing. Since all 3 of these oxygens are exactly equivalent to each other, it doesn't matter which one I take it from. So for sake of argument, because this pair of dots on this oxygen is being a little bit messy, I'm going to get rid of this pair right here. I'm replacing that lone pair with a bonded pair. And now my nitrogen has 8. Right? So again, I draw my Lewis structure. So N, O with the double bond. Why does it keep doing that? Right, so this would be my structure for nitrate. Now, one thing I do whenever I have an ion is I put the ion in brackets and put the charge on the outside. This tells me that I have an extra electron in here somewhere. Right, if it were positively charged, I put a plus on the outside. So this is drawing Lewis structures. I'm going to have a second video up with a bunch of examples for you to look through and try to practice with. You can go through that if you'd like, or you can try to get started on the homework. Again, if you have questions, please ask. Right, so hopefully I'll be receiving your guys' work sometime next week.